Hello, welcome to this session about the Service Bus, Windows Azure Service Bus. My name is Clemens Fastas. I'm a principal technical lead in the Windows Azure Service Bus team in Redmond. In that function, I'm setting the technical strategy for the product, and I'm the architect effectively for the customer-facing features. All these Windows Azure services and Service Bus in particular, because we're kind of a service that sits on everything, are like an iceberg. There's the shiny things that are sitting above the water, and then there's a lot of stuff that sits beneath the water. So the stuff that's beneath the water, we have some other people who are doing that, and I'm kind of dealing with the iceberg with the features that you're using. If you want to follow me on Twitter, we've seen some Twitter interactions earlier. You can follow me at Clemens V. I will try to be interactive, and I am interactive on that account. So if you have questions, you can ask them on Twitter. And also, that same handler is my email handle at Microsoft. So if you have questions, if you have things that you want to do with Service Bus, specifically around scenarios that I'm going to talk about today, and then I'm also going to talk about on Friday. There's an extension session with more scenarios and more details on Friday at 10:30 in Hall 10A. Then I can certainly follow up with that or connect you to folks. So we're talking about Service Bus. What I'm going to do first is I'm going to give you some scenarios. I'm going to talk about some things that we see people do with Service Bus in a particular. We're going to take one scenario, and I'm going to walk you through what people do with them. And then we're going to go and do a little bit of a tour through features and also through things that we've been adding in recent months, and which we're going to add, so towards roadmap, also going to add towards the end of the year, and probably also into next year. So the first is the what and the why. I'm going to talk about SDK and tools. I'm going to talk the access control model. I'm going to talk about brokered messaging, queues, topics. I'm going to talk about the relay. I'm going to explain the pricing to you, how much this costs. And then hopefully at the end we're going to have some time for a question or two. If we don't get to the question or two, then you can certainly come up here or also meet me in the Technical Learning Center later. Let's start with the what and the why. Service Bus is a fabric that sits inside of Windows Azure where you can create namespaces. These namespaces are like sites in IIS. If you have ever created anything in IIS, you know that you create a site, and the site has effectively a host name, and then into that site you can create virtual directories, which means you can go and take any arbitrary directory in the file system and just map that into that namespace. A Service Bus namespace is like this, but it's in the cloud. It's not file-based. It's an abstract notion of a namespace. And I'm going to have a slide about the namespace in detail as I'm talking about the access control service. With that, Service Bus kind of creates a bus. And what you can do is you can plug things, you can plug services into this bus and can interconnect them using what we call entities. We have queues, a simple log that you can go and put data in, and that you can go and get data out on the other side. A topic, which is a log where you can have multiple subscriptions that each can get a message and you can go and filter on. So we're going to go into that in detail as well. We have relays, which allows you to have a service like let's say, a line of business application that sits on premises somewhere in your own data center, and data center in the widest sense, even if that's just a computer that sits under someone's desk. And you can expose a public web service from that machine, even if it sits behind firewalls and NATs, even if it just is connected through a normal, DSL connection behind a NAT. You can go and make a public endpoint, and that public endpoint can then be spoken to. That's the relay. Then we have a feature that I'm going to talk about towards the end, which is about notifications. Notification topics is what they're called. Well, we use the same model that we use for queues and topics, the same brokered messaging model. And we're going to allow you to push information into the shell of devices like one that I'm seeing up here, an Apple iPad or an iPhone, where you can push into the shell. And since you've likely have seen already our wonderful new Windows 8 UI, that has these tiles, and it has toasts, and it has badges, and also Android has those capabilities. So with all these operating systems, one of the new things, one of the requirements is, since the applications are being shut down when they're not active, there is a mechanism inside the shell to effectively get the attention of the user. And that mechanism you'll be able to use with Service Bus. You'll be able to send messages into the shell using that mechanism. So that's something that we're working on right now. And then there's also something we call bridges. That's a feature of BizTalk. BizTalk is building EDI, EI capabilities. So BizTalk is building a set of extensions to Service Bus as a platform as a service solution in the cloud. And so I'm going to give you a pointer to the session that happens on Friday about the future of BizTalk and also the future of what we currently have in the Service Bus Labs environment as EAI and EDI. Let's talk a little bit about the scenarios that I have that I'm hinting at here. One of them, and that's something that I'm going to discuss also in my talk on Friday, is the household appliance. Household appliance or cars or anything that is a device that's not necessarily has a screen, but that's in the house. So I'll give you an example very quickly. Let me go and get my bag. In my bag, I have an air conditioning. That very clearly is an air conditioning device. It's missing a fan, it's missing the cooler, but the rest is obviously an air conditioning. Well, what it has is, it's a main board. This is running on the .NET Micro framework. It has a temperature sensor, it has a joystick, it has a display, it has a relay, which allows me to switch a fan on or off. But this is an example of a device that's not something you buy, you operate on using, you don't browse the web on those things, but they control things in the house. So this mobile device is something if you read the current issue of MSDN Magazine, that you can find online if you search for MSDN Magazine, there's an architectural article about how you can go and create large-scale command and control and eventing solutions using Service Bus. And on Sunday, July 1st, comes the follow-up article, which explains how to do this with a mobile device. I'm going to give you a preview of that on Friday. What we see within the last 6 months is increasing interest by manufacturers of effectively everything that has electronics in it to go and connect those devices up, because you can do enormous amounts of interesting things once you have a connected device. I'll give you an example of, let's say, a coffee maker. Let's say a network-connected coffee maker. How silly is that? Well, if you have an industrial coffee maker and a coffee maker that sits in an office and that is just brewing like crazy, what you want to do is you want to be able to predict when that thing is going to fail so that you can send the technician before it fails. And that's just a matter of customer satisfaction. We have that case as a real case. If you're a car manufacturer and you want to give customers the opportunity to see whether their car is locked because they just forgot it to check it, whether they locked their car, well, it would be nice if you could check whether your car is locked while it sits over in the parking lot. We have a case for that. It would be nice if you could go and broadcast your engine information as you drive a truck, where you are, what the engine health data is, if you're managing a fleet. There's all kinds of interesting telemetry data and also all kinds of interesting command and control data that need to flow. And for that, you need to have connectivity. You need to have a way to create a little mailbox for that device. And so that's something that's interesting with the PubSub thing. You have phone, tablets, and PCs where you have games that are interactive. You have other experiences. You have business solutions. I'm going to get to a business solution in a moment. We have point-of-sale kiosks. Also solutions for also cases for this, where, for instance, you have a company. The company is renting DVDs out of vending machines. The vending machines are outside of drugstores and convenience stores, and you can walk up to that machine, you can swipe your credit card, and then you can rent a DVD for $1 per day, a Blu-ray $2 per day, and an Xbox game or a PS3 game for $3 a day. And then when you're done with that game, you return it. For that scenario, that's a point-of-sale kiosk that sits just somewhere outside of a convenience store. One of the things that they have as a special feature, that particular customer, is you can browse that kiosk. The kiosk has 500 DVDs inside of it. And so there's a catalog that's maintained by that device because it also needs to work offline when the network is not there. So you'll actually be able, from their website, able to reach into that machine and in that machine go and reserve yourself a DVD when you're just driving by there in 20 minutes. So you need to be able to reach that thing. And that thing just sits on a normal network, DSL network, that is provided by the convenience store. They don't even control this. They just hook this thing up. So we see tons of scenarios coming up, and we've been talking about Service Bus for a while, but now we see the customer landscape actually picking this up and actually seeing that need for connectivity. And that's really interesting. And then, of course, the key scenario that we've been driving so far is the SaaS service solutions, SaaS solutions that sit in the cloud that need to go and implement and then talk to solutions, line of business applications that are sitting on premises. So that's the one scenario that I brought for you, so you have a little bit of a feel for one of the things that's being done with Service Bus. So we have several cases. I'm taking a tax advisor scenario. We have a case study out on the Azure website that you can find. LexisNexis is a ISV. They're making solutions for lawyers, for attorneys in the United States. And so this is modeled on the LexisNexis model. We have another customer who's building something that's very similar for the medical field. Now, the medical field and lawyers and tax advisors and a lot of other businesses have particular problems, in quotes, with the cloud or with hosted solutions because of regulations and because of trust issues, not only by them but also by their clients and patients. They typically run their systems inside the house. So they typically have a server. They have the line of business system is the server that sits in the office, in the law office, or inside the doctor's office. At the same time, there's increasing need or increasing demand that a medical doctor can go and take a tablet PC on the road and get at the patient file. The thing that you don't want is to have the patient file loaded into that device and then lose that device. That's not a good idea. So instead, what we see is that we have a number of companies which are using that exact same pattern. They have a mobility gateway that sits as a SaaS solution that they provide for all their customers in the cloud. It's a multi-tenant service. And the multi-tenant service is able to connect down to the various individual offices. And these offices are connected using a normal broadband connection. It's an always-on connection, but that's the only requirement here, really. And so then this gateway here can go and then talk to the individual offices and get the data out. So as you're browsing a customer, a patient file, or a client file, it's actually a call to do the lookup, gets a data package up, and then this gate will go and shred the data appropriately so that the mobile application can get to it. So that's done through the Service Bus Relay. The Service Bus Relay gives the application that sits here, or the gateway that sits here, the ability to create a web service that is request response, and this request response service will then respond to the respective requests. Now, if there are notifications that need to be sent to the tax advisor or to the doctor who's on the road, so maybe there's something that's pending that they need to go and talk to someone about, right? There's a phone notification that happens. Then we can go and from here push data into a topic, and that topic has a subscriber in that mobility gateway, and then that mobility gateway can go and talk to the application directly. Or in another case, if we go over here, if the application is closed, we can go and take that same notification that we sent into this topic, which the application can fetch when it's active. We will be able to push the same notification into this notification mechanism, Apple Push Notification Service, or Android, or Windows notification services, or Microsoft notification services. We're covering all the platforms, Windows Phone, Windows 8, iOS, and Android, and get the same notifications that the application is then alerted. See that blue toast here? To actually open this up. So Service Bus enables the federation of these apps, allows this application which sits on a normal tablet, where it's not practical to set up a VPN solution, where VPN is actually a very complicated solution. Service Bus enables all these communication flows between all those different apps. That's one example of how we see people using this. So what I'm going to show you first is how the relay works. And for this, I need to switch to my demo machine, which is a little more complicated. But I think I'm starting to learn it. So here's a very simple service. I'm trying to make that service as simple as I can make it. So here is a normal and the minimal .cf Windows Communication Foundation service. Let's go and make this a little bigger for the benefit of the people in the back, because it's so simple. And I did this demo yesterday for the Windows Azure user group, so let's go and correct this. Hello, TechEd. So in terms of Windows Communication Foundation, this is very trivial. Obviously, it's a service contract, has an operation contract on it. We're implementing this inline, so there's no separate contract class. And there's a get data method. And this web get here will turn this into a normal web request. So that's the implementation class. The other file here is obviously the hosting model. So, and that's not spectacular. We have a web service host, and that web service host is seeded with the service, and then we're creating, for the address, we're creating a service URI using the service bus construction method, which will go and expand this address effectively to HTTPS, and then your service namespace. The service namespace is your identifier, this, like your site in IIS, so you create this on the portal. Service namespace.servicebus.windows.net, and then we're hanging that under the name /simple service. Those namespaces are something that you create in the portal. This is on the existing portal, not on the preview portal. So there's the section Service Bus Access Control and Caching. There's the Service Bus segment, and here you have your namespaces. I have my namespaces here. Clemens V, Vasters TV, Clemens V6. So these are namespaces that you can go and create, and it's very easy to create your own by just going here and saying new, and then you can go and select a name that's not taken yet, Clemens V8. You pick a country and a region, where you can actually go and pick any of the 8 data centers that we have, and that is relevant because that will determine what your latency is towards the system. So you have the United States options, and then if we're in Holland, we have Europe West. The data center is just around the corner, and then there's Europe North, which is in Dublin. So typically, if you're on the continent, then Europe West is not a bad idea. And then if you're having a solution that's using Asia, then you can use Southeast in Singapore or East in Hong Kong. So you can basically just put your namespace into one of those regions and go and create it. And then once you create it, it will be provisioned in our system. It will materialize, and you can go to the portal, get the key, the owner key, to go and create a connection string. So I've done that already in my demo namespace here. And I've seeded this into my configuration file. So the key difference here for this solution between a normal WCF service and this one is that we're using not the normal web HTTP binding that you would use with WCF, but we're using the web HTTP relay binding. So what we have for the relay specifically, we're using the WCF programming model, is we have a special family of bindings that we made, which look exactly like the standard WCF bindings, but they're connecting through the relay. And we're going to explain to you a little later once we get out of the demo how that exactly works. And what I can do here is I can set a number of settings, and one of the service bus specific ones is here, in this case, I'm turning a particular security feature off. Relay client authentication type, I turn that to none. I'll explain that to you in a moment. And then otherwise, I'm just hooking up that binding to this endpoint in the configuration. And then down here, I have my behavior where I now have my account that's owner. We should have called that root. That's the owner of the account, and then that secret that's being created on the portal. If I go back, by now my namespace may be active. Let's go take a look at that. So there's yes. So that's still activating the one that I just made. So we might go and take a look at that later. So now, very simple service, hosting, and now let's go and start this. So what it just did, or what this does is, now I'm on this network here. I didn't ask anybody for any favors on this network. But this is now a publicly available endpoint. So you can hit this now, and we're going to hit this now here from stage. But if you're a very fast typer, you could actually go and hit this too. Because this is now a public web service hosted on this machine. So let's go and go there. And it will return us some XML, as expected, with Hello TechEd. Publicly hosted web service behind firewalls and NATs and all kinds of protections that are sitting here in the conference center. So you can do that from any machine that can host WCF. You can go and make and expose a service like this. So this one is now not protected. What I can do is I can go and, let me go and shut this down. We need that later. So now I shut down the service. Let's do an F5. Now we're back to the service registry view, so there's nothing in here anymore. So the service is gone. And now I'm going to go and change the configuration. That's all I do. And I'm just going to take the security thing out and go back to the default and start it again. And when I do that same get operation now, what I'm getting is missing token. The request contains no authorization header. Here. That means I can't get to it because we have a security layer in Service Bus by default that requires you that you bring a token to Service Bus to actually get at that service. How that works, I'm going to explain to you later as well. So that's a very simple service. You just effectively just exchange the binding, and with that, you're able to take a local service and expose it out in the cloud, and we're listening on your behalf. What we also can do in this scenario is load balancing. And that's so with this, you get what we've seen so far is NAT traversal, right? Naming, because we give you an external name, so you don't have to register a DNS. We also give you HTTPS by default, so you don't have to deal with certs. And we give you location transparency. I can move that service across the IP addresses and across networks, and it will always have a stable name. Another feature is load balancing and also failover. So if I run this solution, which is using our NetTCP protocol, so it's not using HTTP, I'm starting 3 of these listeners, and they're all sitting on the same name in Service Bus. So they're sharing all the same address in Service Bus. And I have these 7 senders, which are now creating sessions and are sending on those sessions messages. And what you'll see is that the sessions are getting balanced across all these all these services. You can have up to 25 of these services load balanced behind a single name on Service Bus. And what we do here is we're balancing the sessions between those different services. What you can do now for a case where something goes down, you basically just close that one. What we'll see is that there will be an error. The session will, of course, give you an error, but as the recovery logic here kicks in, it will go and now balance across all the other ones. So you get a very easy failover solution. We instantly realize that the listener has gone down, and we will go and then rebalance. So we get a very easy solution for this. So location transparency, NAT traversal, firewall traversal, load balancing, failover is all features that you get with the relay plus that security boundary. So with that, we're acting effectively as an externalized DMZ for your services. You have services that are sitting inside the firewall, even inside a proper data center. And we have customers, for instance, EasyJet. Do we have anybody from EasyJet here? There are the EasyJet people. So one of the things that EasyJet did is they built a little prototype 2 years ago or so. And they needed to take some of the back-end services that they had and needed to pull them effectively to the front. They needed to make them publicly available because their goal is to save money. And one of the things they do to save money is to effectively get around all the expensive infrastructure that you need to rent at an airport to be at an airport and check people in. So they want to do that on their own systems. So they took their internal systems and had to pull them up. Now, pulling that up into their own data center in their own DMZ was a lot more complicated, time-consuming and expensive than just changing the config on their services. And so they did that. They could do this in 20, 30 minutes and started doing the prototype on that. And it turns out that was just perfectly sufficient. And so that's how they roll. So we're an externalized DMZ for scenarios like these where you have internal services and it's just really hard to get them out to the front. So let me just go and clean up. So what we've seen is we have seen 2 capabilities here. We have seen relayed WCF net TCP. That is the preferred way of how we think you should expose your services through Service Bus because it's the most efficient route. So you have a net TCP link. It's a binary protocol. It's a binary SOAP protocol in that case. It has compression inside of it. And so you can take your WCF service that you have and expose it with a net TCP relay binding, and with that get that capability. You can also take any WCF SOAP or REST service. That's the first one that we've seen. This is a plain HTTP REST service, and expose those into Service Bus and then talk to them. And there's something that's coming soon that I'm working on right now. We already have kind of a marketing name for it. We don't have a code name for it. Funny, even though we're gonna run this as an open source project, and so I'm currently writing the code. As soon as I have a code base that's reasonably good, I'm going to put this onto GitHub, and then you can contribute if you wanted to. What this will do is it will plug into IIS. It will plug into IIS and make it possible that anything you can host inside of IIS will be exposed in the most natural, direct way through Service Bus, and then also onto a bridge service in Windows Azure as possible. So if you have applications that sit in IIS, in Node.js, or in PHP, or whatever the technology is, you'll be able to effectively relay them out and not use WCF as we've seen that so far, but effectively take anything that runs into IIS, including websites, and then pull them up. One of the biggest scenarios that we see for that scenario is things like Windows Phone. Does anybody have a Windows Phone? a few. The few, the proud. Yes. So the Windows Phone has this wonderful feature called the Office Hub. The Office Hub is really cool. The Office Hub is really cool if you have SharePoint. It is really cool if you have SharePoint, you can actually talk to that SharePoint. And most SharePoints are internal. So it's sitting behind the firewall. It'd be nice if you could expose for your corporate phones your SharePoint sites so that your phones can actually go and talk to them. So that's one of the core scenarios that we want to enable, that if you have corporate assets and you need to expose them to folks who have an iPad, bring your own devices scenarios, that we'll be able to go and build that bridge. The goal is for this IIS Cloud Bridge, even though we're going to develop that as an open source project, is that the end result of that is going to be so friendly for an IT pro that they can basically just go and take this, download it, do a few clicks, probably put a credit card in because it's for pay, right? Let's be clear. And then run an integration of a site with a few clicks for, let's say, $10, $15 a month, which is acceptable for even a smaller business. That's the programming model that we have for this. The programming model is based on a number of bindings: Web HTTP relay binding, basic HTTP relay binding, WS2007 HTTP relay binding, NetTCP relay binding. So that's all WCF based in the relay. And then we have two special bindings. One is one-way, the one-way relay binding, which is a utility binding that we use internally. Next slide. And then there's a net event relay binding, which is a multicast binding, where you can go and effectively have also up to 25 listeners on a single name. But if you send one message in, then that message goes out to all the listeners concurrently. So that gives you a broadcast option in Service Bus. Up to 25 listeners, not more. If you want more, then you're going to switch over to topics on the brokered messaging side. So the advantage or the characteristic here of the net event relay binding is that it's synchronous, which means you send an event in and all the subscribers will get it and you will not get control back until everybody has gotten the message. Well, that's not true for topics. And then underneath there is if you need to build custom bindings, if you need to do Jedi arts in federated security, you can do all those things and you can compose your own bindings and then effectively just slip in our HTTP relay or HTTPS relay transport binding element under the covers. So how does the magic work? The magic is actually no magic. It's just normal TCP. The receiver will delegate receiving to us. It will do that in the same way as any normal web service on your local machine that's listening on HTTP is delegating the receiving to HTTP sys. Right? So what it will do is it will go and say, I want to have all the requests that are coming in on the following name, on the following path. Whenever you have a request for this, send that to me. So what we do to do this is the receiver will open up a connection into Service Bus on a random node, wherever it gets balanced. That's this one-way path. And we'll go and register that name. A sender will now come into some other node in Service Bus. Right? We have up to 96 front-end nodes practically deployed. We have 32 front-end nodes. And we'll go and create a connection. If there's no route from here, from that node, to your receiver already, because we cache connections, what we'll then do, it will go and send a control message up to that name, our backend naming fabric. And then from there, it will send a control message through this existing socket to that receiver, and the receiver will then create an outbound socket, and they're going to be knitted together, and then they will have a standing socket. So all of this connectivity is outbound. There's no inbound connectivity, and therefore you don't need to have any outbound ports open, inbound ports open. So no opening ports in the firewalls. And if you don't have ports 9351 and 9353 open, 9351 and 9352 open, which is doing that over TCP, we will go and use plain port 80 instead, and we're just adding a feature. We're adding that right now, and we're going to have that in the next SDK 1.8. that you can also do that over HTTPS. With that, effectively every kind of intermediate proxy that sits in an infrastructure is something that we can get around, but at the same time we're trying to pay attention so that there's always a way for an IT administrator to go and effectively suspend that traffic if they really needed to. But typically for those scenarios, we are getting these as scenarios that are supported and actually desired by IT, where IT is using Service Bus themselves to actually go and use us, as said, as an externalized DMZ. So that's typically not causing a problem. Now we get to brokered messaging. Brokered messaging, you have seen if you have seen the foundational session with Scott Guthrie. In the session with Scott Guthrie, he had a message Scott scenario where you could send messages to him from your mobile device while Scott was on stage. We did that through Service Bus message queues. So we're going to go and take a look at a similar sample, not the same thing, but an application that does that. So for this, I'm going to use Visual Studio 2012. And I will go and open a recent project. And let me pick the right one. So we have a MVC3 based website that's not very spectacular. You will notice that I have downloaded a wonderful tool called VS 2012 all caps. It's on NuGet. I don't work on Visual Studio. I believe in proper capitalization. I'm just saying. Shh. So, but I can totally see how this distracts me. So we have this MVC order site. The MVC order site is not particularly interesting as a site. Let's go and start this quickly. Compile, build succeeded, as it should. Here comes a hope. A hope. Come on. I mean, how long can this take? Would you please? Would you mind? There you go. So all this does is it lets me specify username and then how much I want to buy of the rocks and the papers and the scissors and the clouds, and then submit that into order processing. So what we're simulating here is an order processing scenario. The order processing scenario, what we want to do here is we want to, as soon as we take the order, right? This is not a complete set of fields, obviously. You would take a credit card, payment material, you would take all those things, and then you go and take that data, and you want to make it secure somewhere, so that as you're processing the data, and for instance the website's connection breaks down, anything happens, that you don't fumble that data or you don't duplicate that data. So you want to put that into a place where you can flow it, and you can go and work with it. So we're going to submit this through a queue. The queue also gives you a number of additional advantages I'm going to talk about on the next slide as I get to it. So what we're going to do here is I'm going to show you a number of things that we've added to Service Bus and to the Visual Studio experience. And this also applies to Visual Studio 2010. So first of all, there's the Server Explorer. The Server Explorer now has a Service Bus node, so that's new. That's in the SDK 1.7, so the current Windows Azure SDK that you can download. Has a set of plugins for Visual Studio 2010 and 2012. And amongst those is the Windows Azure Service Bus Explorer node. So let me go and make that a little bigger. And what I've registered here is my colleague Abhishek's test namespace. And you see the queues and the topics. And effectively what we're doing with this is we're giving you something that's fairly similar to what you'll see under the servers node. If you go to the servers and you go to MSMQ services, we're going to give you a similar experience here. So with this, you can go and manage queues, so I can go and in the queues node, if I go and right click, I can create a new queue, or I can go into a queue and I can go and delete it, or I can send a test message, receive a message. What I can't do yet here is I can't yet browse the queue. That's a feature that we don't have yet. You would not believe how difficult that feature is. So you can't browse the queue yet. You also can't browse subscriptions yet. But that's something that we're working on that you're going to get here too. So you're going to get, with this, you are able to go and do all the setup work now straight from Visual Studio, so you don't have to include that in your code as you're doing the testing. And the expectation is, as you're deploying things, is you're effectively deploying your services with a deployment script where you're just going to use our API and then have that set up so you don't have to do that as your in your mainline code. So that is one piece. And the other piece that we have is we have now some templates. So I'll go and first make this a Windows Azure application, just as Scott did. So I'm going to add a Windows Azure Cloud Service project here. Which is a deployment project. Now I can go and deploy this into Windows Azure. And I'm also going to add a new role, and it's a new worker role project. And that new worker role project that I'm going to add here will be a worker role with a service bus queue. So that's a starting point that we give you to effectively have a worker role that's using the service bus queue to get the work data in. So the notion here in Windows Azure in the past scenario is they have a website, and then you have backend workers, and the backend workers get their data through the queue, and with that can have looser coupling between the front and the end. As I said, I'm going to get to the benefits on the next slide. So I'm going to add this in here. And so that's going to add that to my project. While that's adding to the project, what we see here is as we parse out the result of the site, as we parse out the result of the site, as I just said, here, we're creating a brokered message. You're going to see the brokered message in a moment, what that is, in detail. But the brokered message is the kind of message that we're handling in Service Bus. So we're creating the brokered message, we're sticking the order object inside of it, and then we're creating a label. The label is something you'll be able to discover and see in as you are evaluating the message. And then what we do is we go and send that message through a queue client that we've seeded in the application itself. So if I go to the definition here, as I hope. Here we go. So in the application, what we've done at the beginning, as we started, is we've created a queue client, and that queue client is being created using a new function that we have here for people who have seen this already. Before you had to create a messaging factory and enter some other things. So now we have a convenient way to just store a connection string inside of the config file, and then that create function will go and pick up the connection string. So that's very similar to how the SQL API works. So you basically just create a client for that queue, and then you can go and take that client, interact with the queue, and we're dealing with all the connection management under the covers. So inside the order site, in the configuration, we will find some config, settings. No, we don't. Well, actually, that is in the web config. I apologize for that mistake, also in the name of my parents. Where are you? There we go. So here's my connection string. And we're going to take that connection string here, which is the endpoint with Abhishek's test namespace, and it's the shared secret issuer. That's the account name. We're going to get to that also in a moment. And the shared secret. So here's Abhishek's complete key. Write it down. Take a photo. If you watch this on the Channel 9 site, this is the right point in time to make a screenshot. Right? So we're going to take this string, and then we're going to put that into the worker role and the worker role's configuration, because that's how it's seeded. So in the settings, it actually has here this pre-populated string where you can go and fill out your data. So we're going to go and get rid of this and basically put this in. And then that code will be ready to run. So this is conveniently using processing queue as the start. And in the run method, it will go and effectively do a receive. If the receive message is not null, which means the receive came back after a minute without any result, that's an empty receive. If the receive message is not null, then we're going to go process it, and the processing we're going to do here is a write line. And then we're going to complete that message. Completing that message means we have several modes of how you can get messages. You can either receive and delete them, which means they're going to be gone immediately as you get them out of the broker. Or you can peak lock them. This is what we use here. It's the default, where you can first lay a lock on the message. You get the message, you can process the message, and then you go and complete the message, which means if you crash between getting the message and completing the message, that message will actually reappear, and so someone else can actually go and process it. So we'll do that here, and with that, we can go and start all this and run it in the Windows Azure emulator, because that's what happens here, is that we switch the... Oh, look, it doesn't. That's the trick with Windows 8 and me. So we're going to go and start this again, but as administrator, it's always good to know. The Windows Azure emulator is actually changing the networking environment inside of Windows in ways that require administrative privileges, since it's being launched by Visual Studio. Visual Studio, as the shell, must be running in administrator mode. So that's what happened to me right here. And drum roll. Let's try it again. And I can actually go and let's go and start the Compute Emulator UI already. It's deploying into the Windows Azure Compute Emulator. Which is here. There's the site. There's a backend role. And so what we're doing here is, as we're setting up the data, we're actually tracing this out. So this is the role that's starting. It will go. So the role state is now busy. And in a second, we'll also see the site pop up. That's not the one. It'll be there in a second. Here we go. And with that site, I can go and now start ordering myself some rocks and papers and scissors. So we're going to do that now. And then we'll see that the message will actually go and say that it has processed the message. So just another 10 seconds of waiting. I apologize for my machine being slow. I don't know exactly why that is. That's probably because my boss hasn't given me an SSD yet. So how about I was about to ask you all to clap so that my boss would buy me an SSD, but too late. So I will go and submit the message. The message now goes into the queue. And once it's out of the queue, we will see that the processing actually happens here in the background. So the message flows through service bus, I think. Or is it not started yet? Oh, here it is. I already missed it. So that's the processing trace that has been made. Well, the flow through time in service bus, it shouldn't have taken that long, so I should have looked earlier. The latency we have through service bus is typically, this is not an official number, you won't find this documented anywhere, is typically we have an NQ latency inside a data center of 30 to 40 milliseconds, sometimes shorter. And we have an DQ latency of also 40 to 30 milliseconds, sometimes shorter, sometimes a little bit longer. So the total throughput, the total latency that we're adding with this transactional durable queue that's in the middle is between 80 and 150 milliseconds. That's what you get. So effectively, for doing processing of data, even in a request-response fashion with correlation, that's something that I'll briefly cover also on Friday. That's absolutely acceptable. So it's not, so queues don't mean slow, and we're actually working to get that latency down to low milliseconds, single-digit milliseconds. So we're working on that very hard. So that was that example. So you have kind of a picture in the code before I tell you about some of the benefits. The benefits you get from this setup where you have this website, which is the sender, and you have the worker role, which is the receiver, is there's several benefits to it. The first obvious one is load leveling. So you get bursty traffic from the front end, web service calls, people submitting things for the website, and you have some workers in the back that are doing some serious work, order processing, things like that. If you put a queue in the middle, now the receiver can do what we just saw in the code, and that is have a loop, which is receive a message, take the message, do the work, complete the message, and then go and fetch the next message. What that means with that loop, that thing never gets overstressed. It has the ability with that loop to process X messages per minute, and that will not change. And if there's more traffic coming in, well, the queue gets longer. There's more messages piling up, but you will not overstress the receiver. So you're creating predictability in that system. You can create parallelism by having multiple receivers sitting on that queue, on a single machine or on multiple machines. The way how you decide of whether you need more workers is you're going to take a look at the length of the queue, so that we have a message count. And based on the message count, you can decide whether you want to spin up more threads, whether you want to spin up more workers. Typically what you will do is you would have a notion of how many messages are typically flowing in, and based on that we'll have workers available. So load leveling is effectively the ability to have bursty traffic on the front but have predictability at the end of it. Load balancing is something that also comes from this, what we call competing consumer pattern, where you have multiple competing consumers all sitting on the same queue, and they're getting messages. And since the queue is a single, well, it's ordered and it's a single a file of messages, you get one message and you lock it, and you process it, and the next receiver gets the next message and locks it and processes that. So you get automatic load balancing across all of your receivers. Also, if you have receivers that are not online, they're not available, intentionally or unintentionally, intentionally in the case of you only want to do the processing once an hour, or you only want to do the processing once a day. We had Scott Guthrie talks in his keynote about cases where we have financial processing companies which are doing financial processing of stock market data, which are effectively doing predictive data analysis for the next day, where they let the trading day go and they just collect the data and they do nothing. They just let the trading day go, and then as the trading day closes, they take the market data and start crunching it to do predictions for what the next day will bring based on the previous market day. They don't run any of those instances during the day. But they'll bring them online and do several thousand instances during the night to do that processing, and then they shut them down again. So if you want to send data to instances that are operated in that sense, you can actually use the queue for offline and for batching. The other offline scenario is you have a connected device, and that connected device is someone's phone or a car that's parked somewhere in the parking garage. If you want to send data to that device, well, you can put it into a queue, and as the device comes online again, it will be able to get its data. The other model is the other entity that we have, are topics. The topic is like a queue, same protocol coming in, same protocol support also in the future it will look always exactly like a queue from the front, but it has multiple outs. You can add subscriptions to a topic. You can add up to 2,000 subscriptions to a single topic. And the simplest subscription is the one where the rule inside the subscription is true. True means all messages that arrive are also selected, are eligible for delivery on that one subscription. Another type of rule you can specify, these are all expressed in a very simple SQL 92 dialect, is like a partitioning rule. You have a number of partitions in your system. Parts of the system are responsible for doing processing orders for everybody whose last name starts with M, whatever partitioning rule you have, and then you partition the traffic up, you partition the data up by some rules. I'm going to get to the rules and how you define the rules and what they're based on in a moment. And then you can go and send that there. The competing consumer notion, so what I said about load leveling and load balancing, is here true as well. So a single subscription behaves exactly like the head of a queue. So you can have competing consumers, load balancing, load leveling, all that is true here as well. So with that you get message distribution, effectively fan out, broadcast, up to 2,000 subscriptions, and constrained message distribution and partitioning. A feature that's not in here yet, but that will be there soon, that's something that we're going to add likely in fall, is automatic forwarding. Automatic forwarding allows you to go and specify for a subscription a forward to destination, which is another entity. And that's the way to break the 2,000 subscription barrier. 2,000 subscriptions is a limit that we set because there's underlying mechanics, so there's physics in the system, right, that we can't get past. There are hard constraints on disk and replication and blah, blah, blah. So we set that at 2,000. However, with forward to, what you'll be able to do is you will be able to go and take a topic, add a subscription, add a forward to into another topic. So you can do 2,000 subscriptions, one for each of 2,000 topics, which each have 2,000 subscriptions. So you can create these, what we call fan-out trees, and then create pretty dramatic, large distribution networks kind of inside a service bus using that simple composition. The messages that we send are effectively based on key value pairs. A SOAP message, as you would know it, will wholly go into the body of this message. So this message is much like the SOAP, much like the HTTP frame, very similar to the HTTP frame, and more like that than what you will know from SOAP. It's actually very parallel. The properties are key value pairs. Simple key, simple value. It's actually these are typed values even. And they map in a fairly straightforward fashion to HTTP in a way that our HTTP protocol that we have for Service Bus, we have a full HTTP REST head on top of Service Bus, so you can use all these features also using HTTP. If you submit a message into Service Bus, the way you express those properties here is you send in HTTP headers. And if you're retrieving a message from Service Bus, that is, you can do a receive or delete, which is a delete operation on the head of the queue. Or you can do a peek lock, which is a post operation on the head of the queue. In fact, you're creating a lock and you get a 201 where you create the lock and then you get the message back. That message will then contain these custom properties also as HTTP headers. It's something that I call privately NHTTP, non-hypertext transfer protocol. Effectively, my rule for this is the simplest form of HTTP is the one where you don't need any parser because the HTTP already has a parser. Because every HTTP stack can actually parse headers. And the HTTP specification says that any header that the intermediaries, like proxies, don't know, they must forward. Which means you don't even have to deal with JSON. You don't even have to deal with XML. You can actually go and express most of your stuff as HTTP headers. And then if you want to make them enumerable and discoverable, just prefix it with something like p-. And then you have your properties, and you don't really need any of the JSON stuff, because that is too complicated. I love sticking a fork into things that are being called very simple. So that's how. So our properties are effectively like headers on HTTP, and they actually map back and forth to headers on HTTP. However, for the protocol that we're strategically going to add to Service Bus this fall, that also has this notion of property. So let's talk about that for a moment. That's called AMQP. AMQP is the Advanced Message Queuing Protocol. And the Advanced Message Queuing Protocol is something that we have been working on with a consortium of other middleware vendors and customers for the last 2 years. The effort is actually a little older than that. We've joined that effort as it was already in progress. My colleague David Ingham is co-editor of the AMQP 1.0 spec. The 1.0 spec has been ratified by the consortium, is now in OASIS for ratification, and we're expecting that to come out as an industry standard in that case then this fall. And coinciding with that, we want to go and add the support for AMQP and Service Bus. And AMQP is a brand new binary protocol, and that's actually has the same notion. It has properties, it has a full type system, and it's enormously efficient also for small scenarios, so that the household appliance thing comes back there. And so that's our new interoperable protocol that we're going to have on here. And you'll be able, we're actually testing against a number of other vendor stacks already. So you'll be able, for instance, to use the C API of Apache Cupid and use the Apache API against Service Bus. So we're testing that to be working. Also, the particular security system that we have, a federated security system that we employ in Service Bus, that will also work with AMQP because we're adding the respective profiles to AMQP as well. We have an HTTP REST head. And then typically, what you will use in your applications is the messaging API, which abstracts you from the protocol choice. So right now we use a protocol we call SBMP, the Service Bus messaging protocol. That's a nickname. It's riding on top of the NetTCP protocol, and we're going to switch that over to AMQP. But if you use the messaging API, or if you use the net messaging binding, which is the brother of the MSMQ binding, effectively, you're going to be isolated from that as well. So you can use the messaging API directly, or you can use the net messaging binding. The messaging API is something that I showed you earlier. That's create a queue, send a message, etc. That's the messaging API. So we made, for the folks who are already using Service Bus, we made a number of fixes based on feedback. I already showed you some of them. We have the config pattern, so you now can go and specify, as you were able to do with the relay, specify all the messaging capabilities, the queues and the topics, all the credentials for this in config. So we have this connection string. We have on exceptions, our messaging exception classes, we now have a flag that's called isTransient. And if isTransient is set, you can blindly retry. So we're helping with the decision of, is there a network issue? Is something temporarily incorrect? If something is transient, you simply retry the operation that's safe to retry. We have a way for you now to tell whether you're connected or not on the relay. So if your route to the server is actually there or not. And one big improvement is that we actually disabled the certificate revocation check against our certs, because that was actually causing more setup time. So you see significant improvements in the initial handshake time there as well. Service Bus also has an access control model, and that's something that you will typically do using the access control service. Let me show that to you quickly. I'm going to go into Internet Explorer's special mode here. No laughing. I didn't say it. And I'm going to go into my Microsoft account. I'm a co-admin on the account, but for that particular feature, I have to log in through my Federation account, so I'm going to do that quickly. This is the backdoor, well, not the backdoor, but the Microsoft way into Windows Azure, because we're actually using our corporate accounts for Windows Azure. The reason they do that is because if they throw us out, then they can terminate that very quickly, and it doesn't hang on the live ID. Yes, because, always living on the edge. We're always at risk of being fired. It's not quite that bad. If you're a vice president, that's a different story. But luckily, I'm not a vice president. So I'm going to go back to the portal in my view, and I'm going to pick one of my namespaces. We're probably going to go back to the Clemens V8 namespace that I just created. If that happens within the next 12 minutes of me having this talk. Well, my issue here is that, of course, I have a lot of stuff that's here, so that's loading. But it should load in a second. Well, let's optimize around to time. I will promise I will not skip the demo. Let me go to the theory first. So the service bus namespace is a tree. So like an IS site is a tree, the namespace is a tree. So you get a root, and you can hook up services, you can hook up queues under the root. If you just create queues with names, you're just going to get a flat list. It's the first level of the namespace. But you can go and create effectively paths as you would be able to create paths on any website. And now you can use that hierarchy to effectively secure the site. So you can assign rules to all these nodes. And we have some very simple rules here. We have 3 rights: send, listen, and manage. Send allows you to send data. Listen allows you to get data, to receive data from a queue, or to listen onto a name on the relay. And manage allows you to create an entity, to create a queue, create a topic, create a subscription, etc., etc. Those are the rights. If you use owner, which is root, you can do all those things. So whatever you can do with the Service Bus API, in the simpler case, everybody's typically using owner, and that's why you don't see the security system. But the security system actually allows you to do very fine-grained security. So you can create an account called John, and you can assign John manage, and then manage logs in with his own credentials, and then he can go and create things underneath here, and he can actually go and assign rights to Fred and Alice and Peter. Now, why would we want to have different rights here? Let's say you make a queue or a topic for telemetry. So Fred has a device and Alice has a device, and they're sending telemetry data in. You don't want Fred to be able to steal Alice's telemetry data. So what you do is you have a third party, the system, or acting as Peter, which actually has the listening right to actually drain the data out. So you can do fine-grained access control based on users or based on device IDs. That's what we often see, that people are assigning accounts, a GUID account, to a device, and then the device can go and listen on its subscription. It can send to its telemetry topic, and then you have a corresponding other service which can go and do the talking to them. So how you manage this is how you can manage this. You can either manage this straight through ACS or using the SBAZ tool. So let me go and show you that. So here we have now my namespaces. Let's go all the way to the bottom. This is what we just created. So that's a wonderful, fresh, new namespace that I just built. And if I go to the access control service here, then it's going to open up the access control service portal for my namespace. And you're going to see the relying party applications. The relying party applications here is Service Bus. And that's how that's being set up. What you'll see in the bottom is you see some red here. And what that means is that we own the signing key. And we seed the signing key in here, so you can't get at the signing key. So only this ACS instance can actually sign tokens for your Service Bus instance. We're going to change that. We're going to open this up. Also, probably towards the end of the year, where you'll be able to get your signing key, and then you can run any other STS, if you like, against Service Bus. But right now, you're constrained to using ACS for that scenario. But ACS is kind of the overlay, the security overlay over Service Bus. That's where you actually manage the roles, which is creating an illusion with the little tool that we're going to show you of having that tightly integrated. So what I'll do is, so this is that application. Then there's the identities here. We have the owner. The owner has a symmetric key. So let's go and grab that symmetric key here, which is the owner identity for that namespace, and let's go up here. And here's my SBAZ tool. So SBAZ tool is the tool that are built for that purpose, and that's included in the SDK. You can actually get that also from the sample site. So we're going to go and first store that information. So we're going to say SBAZ tool, and then we're going to say namespace is Clemens V8, and the key for that is the key that I just copied. And then we're going to say store options. And what store options does is it effectively takes my name and my key, and if I say here show options, then it's going to give you the data that it's stored. So it's putting that into the application's local storage. And now I can go and say SBAZ tool make ID Peter. So what that does is it goes out to ACS and just creates a new identity. So now I can go back here to the list of my identities, and there's Peter. And now I can go and say SBAZ tool grant send on foo to Peter. I can now say SBAZ tool show me the rights that are existing on the root. So that's the owner has rights on the root. And now we're going to go and look at foo, and you'll see that owner has rights because they inherit, and then Peter doesn't have inherited rights. He has now send rights on that. So with that, you can go and create those accounts, and those accounts you can use with the API to basically, instead of owner, use that account, and that account will now only be able to interact with the entities that are sitting in the respective branches of that namespace with those rights, and they can't do anything else. So complete fine-grained security built in, interacting with ACS. And SBAZ tool is a tool that you can download from code.msdn.com, I think. So where the Windows Azure samples are, you can get that SBAZ tool from there, compile it, and it also comes with a library that you can go and integrate into your code. The article that's going to come out on Sunday, which I talked about the devices, is actually also using that for that purpose. So, then, more demo, quickly. We have 4 minutes to go. For Windows 8, we're also having an SDK. That is something that you can get from GitHub that sits alongside all the other Windows 8 SDKs, where we have 4 Metro-style apps, a whole set of a full client for the Windows Azure queues and topics. So you can very easily integrate them. So that's primarily for the asynchronous messaging. So you can very easily create a queue. So the Service Bus Explorer, this application, is actually part of the SDK. So you can go and create a queue. And you can send a message. And you can receive the message. I said receive the message. Did I send it? Let's say I received it. I would fix it, but we're kind of running out of time here. Well, you can go and download it from the SDK. It's all pre-release software, so I just blame it on that. And then we also have an SDK that's out for Node.js. We have an SDK for Python. So we have all these SDKs that are that you can use to build applications based on Service Bus in all these different environments. Pricing, kind of important. The pricing is $1 for 1 million messages, 1 cent for 10,000 messages. You calculate this in euro, then it's going to be under 1 cent. Obviously, a message is a message you send in or a message that you get out. It's up to 64K in size. If you send a message that's 256K, it's 4 messages. That's 64K message blocks. If you use the relay, every 100 hours we charge you 10 cents per endpoint. So if you have one of those load balanced endpoints and you have 25 listeners, it's not per listener, it's not per connection, it's just for that one endpoint. So it doesn't matter how many listeners you have, it doesn't matter how many connections you have with just that one listener, that one endpoint is something that you pay for. And then you also pay for the Windows Azure Data Center egress charges. If you do the calculation of what that means to most common applications, it's not a lot of money. So futures, of course, I'm already out of time. So let's race through those very quickly. The first one is Iguazu. So I talked about the push notification features. That's the push notification feature. I'm going to skip to this slide, which is actually giving you the core story. The device will go and use its normal API to create a toast in Windows 8, similar in iOS. It will create whatever it needs to do to register. So whatever you would normally do to register with a push notification system, what's different here about what we build is that we're separating out the notification data from the notification that actually is being sent. Here, we're actually keeping the UI design with the application. The application is using its own API, the Tile API, the Toast API, whatever the local API is to create a local notification. And we're using that, and then we'll allow you to put placeholders into that payload. And then you give us that object, and we'll take that object and we give that to the server. The server will now have this template, and it's going to store that template for you. And if you have 5 million devices, that's fine. If you have 10 million devices, that's fine. And we get a message in, like a weather alert here. We get the weather alert in, and now you've done a customized mapping. You say, I want to have my tile in red. I want to have the localized Russian description. I want to have the temperature in Celsius. So you're going to do all the mappings, including you can add literals. And then we're going to go and take this notification, this message, and map it onto custom for the device, and then are going to push this out. So you can have 5 million different targets, and I'm not kidding, 5 million different targets, and we're going to push notifications, customized notifications to all 5 million of them. And there's also further features we have called tagging, where you can actually go and address subdivisions. So that's something we hope we're going to have in preview towards the end of the year. It might be that it's December 65th. We'll see. Trying hard. Service Bus EAI, EDI. If you're interested in that, go to at 1, a Friday, Hall 10A. You're not going to miss my talk. My talk is also in Hall 10A at 10:30. And then we're currently not in the new portal. You've seen I've been using the old portal. So the new portal is we're going to be in there. We're going to have statistics. We're going to have all those things. So I just lifted those things. So it'll be in there. And that is what I had for you. So we've seen some reasoning. I've shown you some basics, relayed messaging, brokered messaging, the SDK and the tools, access control. If you have questions, come to me. Also come to the session on Friday at 10:30. And with that, since I'm out of time, thank you very much for coming.